Okay, so let's solve another questions of lines. So the question says there is a line PQ. True length is 85. Apparent lengths are given 75 and 80 in top and front views, and the location of point P is given. So please draw uh, an XY line, and then please draw a vertical projector line towards the left part of the XY line to locate the point to locate the points P dash and P in front and top views respectively. The distance above XY or above HP is 10 mm, and in front of EP or below XY is 15. We can locate the points P dash and P and draw horizontal projectors passing through these points P dash and P parallel to XY. After this, we have to draw the apparent lengths on these horizontal projectors. So, taking front view length as radius and point P dash as center. Okay, front view length as radius and point P dash as center. Cut an arc on the horizontal projector line passing through the point P dash. Name this length as front view length. Similarly, take top view length, which is equal to 75 mm as radius, and point P as center. Cut an arc on the horizontal projector passing through the point P and name this distance, this line segment, as TVL equal to 75 and the FVL is equal to 80. Now we have to take the vertical projectors from these endpoints. So the vertical projector from the top view length will go into the front view, and the vertical projector from the endpoint of the front view length will go into the top view. So draw these lines. Vertical projector through the endpoint of front view length into the top view. Okay. After this, we have to take true length in our compass, which is 85. Take point P dash as center and cut an arc on the vertical projector coming from the top view. So this is the relationship between the apparent length and true length. When the apparent length is parallel to xy, we take the projector into the opposite view, we get the true length at true inclination. So we have taken true length in the compass and taken P dash as center and cut an arc on this vertical projector. Now this point should be point Q1 dash, but in this video wrongly point Q has been represented by point B by mistake, so kindly excuse that part. I'll refer to this as point Q1 dash itself, and this is a true length. Similar to this step can be repeated in the top view as well. So please take true length in the compass, take point P as radius and cut an arc on the vertical projector coming from the front view. This point would be point Q1. Okay, so this is true length and point is Q1. Okay, now we can draw the locus of point Q dash in the front view passing parallel to xy through point Q1 dash. Similarly, we can draw the locus of point Q in top view passing through the point Q1 parallel to xy. This is where we'll get the final projection points Q and Q dash as well. Now everything is complete. Only thing remaining is to rotate the arcs of front view length and top view length. So please take front view length in your compass, take P dash as center and cut an arc over to the locus of point B dash. Similarly, take TVL as radius, point P as center and cut an arc over to the locus of point B. Wherever these arcs are intersecting the loci, please join them by straight lines with points P dash and P. These are the final projections of the line, and the points can be named as Q dash in the front view and point Q in the top view. And the inclinations that these lines are making with xy are the apparent inclinations alpha in the front view and beta in the top view. And beta in the top view. We can measure these, and these are the answers. So the question was requiring true and apparent inclinations of the line. So true inclination can be measured with respect to the angles made by the true length with the horizontal projectors passing through P dash and P in the front and top views. And similarly, alpha and beta can also be measured.